All right, we are working on number 9, part 3. We're on part 3 of flippin' Ferraris. So question number 9 says, what do you notice about the graph of S of D compared to the graph of D of S? You should hopefully already compared your two graphs and have a few things written down. So here's some things that I came up with. Both of the graphs are curves, right? Both graphs are curves. They're kind of going in the opposite way. I don't know if you noticed that. Going in the opposite way, but both are increasing. So they're just increasing differently. So if you look quickly at the graphs, let me pull them up. We have our S of D graph, it looks like this. And then our D of S graph looks like this. So you see they're both increasing, but this one's kind of like curving that way, and this one's kind of curving this way. But they're both increasing. So one of them seems to be maybe increasing faster than the other. This one might be going quicker because it's going up faster. It's taking a little bit longer to then start going up, but then it starts going faster up here. So they're both increasing, both curves. Something else that you may have noticed is they both are functions. They both pass the vertical line test. The inputs and outputs, you may have noticed some of them are the same but swapped. So looking at let me pull it up again, our two tables, not all the numbers are the same because we didn't use the same inputs all the time, but we have 0, 0, which matches, and then we have 100, 300, and this one's 300, 100. And then we have our max. I don't have the max written down here for some reason, but our max was the reverse also. 217 was our max speed, and then 1,412.67 was our max distance. So the inputs and outputs are swapped, even though we don't see that in our tables. We can see it with select points because we didn't use, like if I look over here, the output is 0, 12, 48, 75, 147. I didn't use those numbers here. I used different numbers. So we're getting points that are in between and different points, but there are some select points that are exactly the same, but the inputs and outputs are swapped. So what does that mean? If our inputs and outputs are swapped, or switched, what does that tell us about the two functions? And that's kind of the second question here. It says, what is the relationship? If the inputs and outputs are switched, that means that they are inverses. Oops, then they are inverses. You may also have realized that they are inverses because they are reflections of one another. A little bit harder to see because the graphs are separate. I'll show you a quick graph of them both graphed together, and I'll show you how they are inverses. All right, looking at the two graphs, you can see the original function is in red with the blue dots kind of going up on the left side of our graph. Then we have our function for speed, which is blue, kind of on the lower right part of the graph. And then you have the dotted orangish yellow line coming through the middle. That's our y equals x line. So looking at these two graphs together, you can see that they're mirror images of each other. The red one, if you reflect it over the dotted yellow line, it becomes the blue one. Blue one, the same thing. It's a mirror image of the other one. And you can kind of see it where they crisscross each other and match perfectly on both sides, kind of like a butterfly. All right, next we're going to talk about a little bit about what's been going on. And we've been working with this real life situation, talking about cars and their speed and their distances. But mathematically, when we take the square root of something, so you do a square root of a number, like for instance, square root of 49. The calculator is going to tell you the answer to that is 7. But in fact, we should have been including this plus or minus sign in our answer. It's really plus or minus 7. And so what that means is when we put this in front of a number, it means that it can be both positive 7 and negative 7. Now, why is that the case? Why are we not using the plus or minus sign for our speeds or our distances in these situations? Well, why are plus and minus even both? Why is that a thing? Why are both of those an answer to this question? Why is the calculator only telling me 7 and I'm supposed to know that it's plus or minus 7? If you think about what a square root does, is it undoes a squaring of something. So what number squared gives you 49? Well, 7 squared equals 49, but also negative 7 squared equals 49. So it doesn't matter which one I'm squaring, I'm going to get 49. When I go backward and I try to go backward, the calculator can't tell me two different answers. It just automatically goes backward and gives me this one. So I have to know that it's also negative 7. It could be 7 and it could be negative 7. So really, when we take a square root, we have two answers. We have plus or minus 7. Why, though, were we not doing that or using both of those solutions in the problems that we were doing with our speed and our distance in our Ferrari? So take a second, think about why that might be. Explain why you think we do not use the plus or minus sign for our speed and distance situation. Pause the video now and come back to check for the answer. All right, x equals negative 7. If I was thinking about what this means, x equals negative 7, that would either mean that your car is traveling negative 7 miles per hour or negative 7 feet. Both of those situations are not something you can do. Speed isn't negative and distance isn't negative. So we wouldn't include the negative answers in our real life situation. Do those negative answers actually exist when we're looking at functions without a real life situation? They certainly do. But because this specific situation doesn't fit with those negative numbers, they're not really in our domain. So we only looked at from 0 to 217. Numbers higher than 217 weren't in our domain because they're too big. The car can't go that fast. Things smaller than 0 aren't in our domain because they can't go negative amounts of feet or negative amounts of speed. So let me write that down real quick. X equals negative 7 would either mean your car was traveling negative 7 miles per hour, or negative 7 feet for braking distance. Both of which are not possible in real life. So we really only considered the positive parts of the x values for our domain, 0 and positive parts. Now we want to consider this function, though, over the domain of all real numbers. All real numbers means positive numbers, negative numbers, whole numbers, fractions, decimals, 0. Every single number you've ever thought of are considered real numbers. Not just the domain that we did in this problem. So in other words, if we include negative speeds in the original function, t of s, make a quick sketch of what you think it would look like. Also describe in words the difference between the two graphs. So take a moment to think of Our graph looked like this to start when we only included the positive numbers for speed and distance. If we were to now include negative speed or negative distance, so negative x values, what would this part of the graph look like? Pause the video quickly, make a quick sketch, do it in pencil, and then unpause to see what mine looks like. Taking a look at question 12, our original S of D would be here. If I then include negative speeds, it will do the same thing, but across the x-axis, it will reflect down here. So we'll have the same curve, but mirror image down underneath the x-axis. So is the inverse of D of S a function? Hopefully you're looking at the graph and making a decision. There's only one place on this graph where I can draw a line where it's going to touch the graph only once, and that's right here. If I draw a line along the y-axis, it's going to touch the graph right at 0, 0, and that's it. That's the only place it only has one input with one output. Anywhere else I draw it, if I draw it here, it's going to have two intersection points, here and here. So x will have two different outputs. I could draw it anywhere else on this side of the graph in the parabola, and there'll be two different outputs for whatever that input is. So this is not a function. D of S is a function, but S of D is not a function. And that's only if we consider it over the entire domain, positive and negative and 0 x values. This is not a, S of D is not a function because it would fail the vertical line test. In multiple places. Anywhere past where x is 0. Unless we restrict the domain. And what that means is we make the domain only some values of x. If we restrict the domain of the original function, with a real-life scenario, then when we take the inverse, it will be a function. And that makes the original function invertible, or have invertibility. I'm going to jot that down here. It's a new word for us. Invertibility. We'll talk more about that the next time I see you. Thank you for watching.